In this lecture, we are going to be discussing about the security measures in databases, the security concerns in the databases, and basically how security can be implemented in databases. Now, security is something very important, not only from the point of view of the databases, but in general from the functioning of the organization. If there's any security breach or security penetration, so that security breach or penetration would result in losses and damages to the organization. So we must ensure, or the organization must ensure, proper security of the system. That includes the database system and as well as the operating system and the general network infrastructure, so that there are no security breaches and no problems and no damages caused by security breach. So let's talk about database security. What is database security? The mechanisms that protect the database against intentional or accidental threats. So threats can be of two types. There can be intentional. Someone wants to create that threat. It might be a hacker, it might be some person who doesn't like the organization or whatever. Or it might be accidental. For example, system crash, power failure, etc. Right? This is all very important because the database represents an essential corporate resource. So your database is a very important and essential corporate resource that should be secured and protected. Otherwise, if the database is down, everything goes down. Just imagine the giant e-commerce websites that are running like Amazon, eBay, etc. right? And even the social media platforms, right? If any of those databases crash, the whole platform and organization is bound to crash. And what are the types of damages we can have? We can have theft and fraud. Your information is stolen and used, right? Loss of confidentiality or secrecy. And information that was bound to be confidential is lost by you. And people have access to that confidential information. So it's a great threat. Loss of privacy. Your private data is exposed. Loss of integrity. Your data is no longer integrity. It has been modified. It has become bad. It has become inconsistent. Okay. And last but not the least, loss of availability. Your database is not available for any reason. If an attacker or a threat makes your database go offline, then the database is unavailable. You might lose billions of rupees in revenue and many customers because your database is not up. Now let's look at about threats. What is a threat? A threat is any situation or event, whether intentional again or accidental, that may adversely affect a system and consequently the organization. So a threat may be accidental or a threat may be intentionally created. So a threat may be intentionally created by an attacker or a hacker, or it might be accidental. So threat may be caused by a situation or event involving a person, action or circumstance that is likely to bring harm to an organization. So what the harm may be? It may be tangible, such as loss of hardware, software or data, or intangible, such as loss of credibility or client confidence, right? If an organization leaks, for example, a set of credit card numbers, so in future people won't do business with that organization, especially using their credit card. That is called basically loss of credibility. So what is the problem? The problem facing any organization is to identify all possible threats. So therefore, as a minimum, an organization should invest time and effort in identifying the most serious threats. So threats might be serious and threats might not be serious. So the time and effort and the money involved in preparing against the threat must justify the cost of the threat, right? It should not be the case that we are spending thousands and lakhs of money on a threat which is bound to cause, let's say, 500 to 1000 rupees damage. So that won't be feasible. So plan according to the type of the threat. So these are some examples of threats, right? Using another person's means of access. This is a threat for theft and fraud. It is also a loss of confidentiality, because you might have stolen passwords, right? It would also involve loss of privacy and so on. Then similarly, working on this thing, theft of data, programs and equipment comes under the category of theft and fraud. Yes, it is. Loss of confidentiality, yes. Loss of privacy, yes. Loss of availability, yes. It is no loss of integrity, because no data is changed, right? No program is altered and no data is changed. This is just like stealing a program from an organization or stealing equipment. So these are different types of threats, and if you look at data corruption owing to power loss or surge, it is definitely only an attack comes under the category of loss of integrity and loss of availability, and nothing else, and so on and so forth. So these are some of the threats that are happening against different kinds of activities. Against the hardware, you might have fire, bomb, floods, data corruption due to power loss, failure of security mechanisms giving greater access, right? Theft of equipment, if someone runs away with your server, so that's a threat, right? And in the communication networks, you can have wiretapping, which is a threat. Breaking or disconnection of cables, threat. Electronic interference and radiation, which is a threat. Breaking or disconnection of cables might be intentional, right? Might be created by intentional activity, whereas electronic interference or radiation might be a coincidence. So against what are the threat against databases? DBMS and application software. Failure of security system giving greater access, right? Your access levels are elevated. You are able to access the root user of the database, right? Program alteration, theft of programs. And what can be the threats against database? Unauthorized amendment or copying of data, theft of data, data corruption due to power loss or surge, etc. Now this is basically the levels of threat by the level of users, right? So if we have a common user, what is the type of threat? Using another person's means of access, right? Viewing and disclosing unauthorized data, and inadequate staff training is another threat at the user level, right? Illegal entry by hacker, again. Blackmail, protection of viruses. And at the level of programmers, operators, creating trapdoors. This is the threat. Trapdoors are vulnerabilities in code that are left intentionally by attackers. This trapdoor is not known by the general public, but the programmers, operators know that, right? So they might be able to exploit that. Program alterations, such as creating software that is insecure. Again, inadequate staff training is again a threat at this level. Staff shortages or strikes, that is the threat. Database administration, what is the level? The inadequate security policies and procedures. A security policy is a very important document in any organization, right? And security policy describes basically the type of security measures that you can have and the security measures you should have for that particular environment, right? And security policy is laid out by all organizations for their secure or sensitive information. Security policy is one thing that never describes a person by the name, right? It always describes a person by the role that the person. For example, the security policy might say that a user should have these accesses, and the user should not have these accesses. And the security policy would say that the network administrator has got these responsibilities. It doesn't matter if the network administrator is Mr. Arif or Mr. Shahid or whatever, right? And so on. So security policy is one of the very important documents in an organization. So what are the countermeasures? Computer-based controls. So one of the countermeasures which are computer-based controls are authorization, access control, views. We discussed about views, remember? Backup and recovery, integrity, encryption, RAID technology, redundant array of inexpensive disks. So RAID technology can be implemented, okay? So this is a diagram that is giving us a very beautiful view of basically how the things are operating, right? So we have our organization, right? And we have our organization, we have this DBMS server. So DBMS server has got the controls of authorization and access control that is built into the DBMS server. And these local clients can communicate with our local system. This is the database. And we have this secure internal network which is called as the intranet, right? So intranet is secure and intranet is trusted. So our secure intranet is connected to the internet through the firewall and through the encryption mechanism through the insecure external network, for example plain internet to the world, and by encryption methods to a remote client. So if we have a remote client that has to communicate with our secure system, that remote client can be authorized via encryption to communicate with our secure system of the database management system. So this is basically the idea. What would encryption do? Encryption encrypts or scrambles the information that is flowing out, right? Our plain text or the plain information that is flowing out of this network would be encrypted or made useless by the encryption algorithm to be transmitted on the internet. So what we can say is that the data and organization that we have, it's called, let me use this thing, it will be much easier, plain text, okay? So plain text basically passes. So looking from the transmitting side, the plain text is converted from the transmitting side by using an encryption algorithm to something which is called as the ciphertext, which is basically something really scrambled, right? Now the ciphertext, which is a scrambled version of the plain text, is transmitted by the transmitter over the internet. This ciphertext is received by the receiver, and the receiver uses a decryption algorithm to convert this ciphertext into the plain text. So what is the advantage of encryption? The data that is traveling over the insecure internet is not the plain text or the plain information, it is basically the ciphertext, which is very difficult and almost impossible to decipher or to find out what it means in plain text. So plain text is safely transmitted as ciphertext over the unsafe or public internet. The ciphertext is received by the receiver, and the receiver uses a decryption algorithm to convert from the ciphertext to the plain text. So what it means is that another element which is called as a key is responsible for the event, right? The transmitter has a key. So transmitter uses the encryption algorithm Now how does encryption occur? Encryption occurs with an encryption algorithm and also by using a key. Similarly, decryption algorithm also occurs with the help of the key. Now key is basically a secret combination or secret word. It can be thought of as a password that is known by only the transmitter and the receiver and no third parties. So transmitter can use the key to encrypt and receiver can use the key to decrypt the information. Of course, if the key is disclosed, the communication is compromised. So over here the key is the same for the encryption as well as for the decryption. So these kinds of systems are basically called symmetric, right? There might be other systems that are called asymmetric, right? They might involve different keys for encryption and different key for decryption. Now in asymmetric encryption, every user has got two keys, the public key and the private key. So user A has got public key A and private key A. And similarly user B has got public key B and private key B, right? So public keys are known publicly, right? Public key of A is known, public key of B is known, and so on, right? So what happens actually? Let's say user A wants to send a message to user B. So user A encrypts using the public key of user B. Anyone can encrypt using the public key of B because public key of B is known by everyone, right? So this encrypted message reaches user B, but only user B can decrypt the message by his own private key B, right? Because these keys work in pairs. So no one else can read the message except user B, because only user B has got the private key of himself or herself that is used for decryption. And similar is the case. So if user B wants to send to user A, user B would increment using public key of user A, and the user A would use his own private key or her own private key to decrypt the message. So this is called asymmetric encryption. Why? Because the key for encryption is different and the key for decryption is different. So one of the well-known algorithms is the RSA, which is short for Rivest, Shamir and Alderman, which are the creators of this asymmetric key encryption.